So you need to feed a new motor, pump or compressor from your power system and the vendor or contractor insists. You need a soft starter. Well, maybe. Hi, I am Fabian with Altus Dexter. In this video we're going to discuss motor starting. What happens, why, possible mitigation strategies, and more importantly, a methodology to determine true necessity. When a motor is connected to the power system across the line, which means directly into the voltage supply without any reduced voltage starter in between, two things happen while the rotor gets moving: excessive currents and voltage sags. Why does this happen? Well, the current that the motor draws is somehow inversely proportional to the speed, so at zero or low speeds, the motor behaves like a short circuit. On the other hand, high currents usually result in voltage drops. If the motor is correctly designed for the application and the voltage sag is within acceptable limits, the torque of the motor will overcome the mechanical load. It will accelerate and things will soon get into normal conditions. However, if the voltage sag is too deep or too long, not only the motor will be subject to this vicious cycle of less voltage, less torque output, which never ends well, but in the process your electrical protections will go wild and take down your system. So how do you decide whether this will happen, and more importantly, if you need a reduced voltage starter? Well, it depends a lot on the strength of your power system in relationship with the size of the motor. Let's see this with an example and some simulations. We're going to use this straightforward industrial power system. One diesel engine of around 1300 kilowatts, feeding two voltage levels with a typical transformer in between. We will simulate how the start goes with three different motor sizes driving a centrifugal pump, 100, 150 and 200 horsepower. We're going to simulate this system in a tool called Simulink, which is commonly used in science, technology and engineering applications. You can see how a single diesel engine the size of a typical one in oil and gas applications may be able to start across the line one motor of 100 horsepower. Will struggle a lot with 150 and for sure won't make it with 200. Let's see how those compare when put together. The 200 horsepower case never reaches the intended speed and depresses voltage permanently. In a real life case, this would have taken down the system. What you see in green is typically accepted ranges of operation, which of course vary per jurisdiction or applicable standard. Voltage is usually limited to no less than 80% in transitory cases. So even though the smallest motor can start relatively fast, it briefly transgresses voltage limits over here. It may or may not need a soft starter, which at a premium mitigates this issue. The other two cases in our example for sure cannot be started across the line. Obviously, this is just an example that could extend into infinite possibilities. More or bigger engines, smaller impedances in the system, different transformers, cables, etc. What matters is that when confronted with the case, true necessity can be determined with the appropriate power system skills and tools, before spending money on potentially needless equipment. If, after diligent analysis, it is determined that you truly need a reduced voltage or soft starter, there is plenty of options out there. Star Delta, auto transformer, and resistance-based methods are cost-effective and relatively simple, but primitive in terms of controllability, whereas solid-state options like VFDs or soft starters are more expensive but also more sophisticated. It all depends on the application. At Altus Dexter, we possess the expertise and tools to help you navigate these complex decisions, so you only invest in what's truly necessary for the specific circumstances of your system. Visit our website or contact us to learn more about how we can assist you. If you want to read the full article on this topic, hit the link below. Thanks for watching.